Okay, hi folks. This video is about adding and subtracting rational expressions, and more importantly, finding the LCD. So I'm going to do a couple of simple adding and subtracting questions, and then I'm going to look at finding the LCD. That's important for the next part because the denominators are not going to be the same for the rational expressions that we're going to be adding and subtracting together. So here it goes. All right, so if we have rational expressions that are added together that have the same denominator, so let's look at something like 2x plus 4, and that's divided by x squared minus 9. And let's add that to 7x minus 10 over x squared minus 9. Okay, so same rules apply that we learned years ago. When we're adding fractions, if we have the same denominator, all we do is add the numerator together. So let's treat this exactly like we would any simplification. So we've got 2x plus 4 plus 7x minus 10. And that's all over x squared minus 9. Okay, so then we've got 9x minus 6, all divided by x squared minus 9. Okay, so that's your simplified version of it. We also need to make sure that we state any restrictions. As we know, the restrictions here are anything that makes the denominator 0. So x cannot equal plus or minus 3. Okay, so now let's look at an example where we're subtracting rational expressions, and again they're going to have the same denominator. So I've got 10a plus 5, that's divided by a times minus 3a minus 2. And that's all over AB. Okay, so notice we've got that subtraction sign, and it's subtracting this whole expression here, 3a minus 2 over AB. What usually happens when you have a subtraction sign right before a negative, it applies to the whole thing, right? So just be careful when you're doing this that you remember to do the following. So we've got 10a plus 5, and that's subtracting 3a minus 2, that entire numerator all at once. And then we've got that all over our AB. Okay, so what I like to do in this case is take your subtraction sign and multiply it through the bracket so that you don't muck anything up. So we've got 10a plus 5 minus 3a plus 2. Notice that sign change? And that's all over AB. Okay, then just simplify it, folks. Okay, so we've got 7a. We've got 7a plus 7, and that's all over AB. And our restrictions here are a can never equal 0, and we've got another variable of b, and it can never equal 0. Okay? All right. This is an important part here. You need to make sure that you know how to find the LCD, because in the next part of this lesson, we're going to do adding and subtracting of rationals that don't have the same denominator. So we know the only way to add and subtract rational expressions is if they have the same denominator. Okay, so let's look at a set like 1 over 2x, 1 over 3x, and 1 over y. Okay, so the three denominators here are 2x, 3x, and y. What I like to do is I like to break it up into three pieces. Okay, or well, sorry, I should say three denominators. I've got my denominator for one of them. Let's see how they all end up sharing. Okay, so for this one here, let's call this denominator 1. Okay, I've got a 2, and nothing else has a 2. Okay, so I'm going to put 2 in its own thing. And then I've got my 3x here. Notice that nothing else has a 3, so I'm going to put my 3 here. I've got a y here. No other denominators has a y, so I'm going to put my y so it's all by itself. Now I'm going to look at what elements are shared in the denominators. So here I've got an x and an x. So these two these two rationals share the x. So I'm going to put the x right in there. Okay, this is just a nice way of organizing things. If two denominators share any factor, I only need to write it down once. So then here my LCD turns out to be 2 times x times 3 times y, which simply is 6xy. Okay, let's have a look at another one. Okay, so this question has 3 rationals again, and I want you to notice right off the bat here is that we've got an x plus 5 in this first one. We've got an x plus 5 in the second one as well. So there's a sharing. They're sharing the same factor. Here we've got an x plus 4 in the first one and in the third one as well. So they're sharing that same factor. And then here we've got an x plus 7. I don't see an x plus 7 anywhere else in the denominator, so there's no sharing of that one. All right, so what I like to do is I like to draw myself 3 circles, basically a Venn diagram of 3 sets. And for the first denominator, I'm going to set it up. So let's say that this is my first one here, and that's my second one, and that's my third one. And, you know, obviously this is my first, second, and third. Okay, so that's how I'm going to organize it. Now, in my denominator of the first one, I see that there is an x plus 5 that's being shared in between with the first and the second one. So then I'm going to put my x plus 5 right in there. Okay. Next, I'm going to look at my x plus 4. And that is being shared between the first and the third one. So I am going to put my x plus 4 right in here. That's being shared by the first and the third. And I'm also going to notice that my x plus 7 isn't being shared by anybody. It's all on its own, and it's just in my third rational. So that's going to end up right in here. Okay, so now my LCD for this guy is x plus 4, x plus 5, and x plus 7. Okay, so let's have a look at one more example, and then I'm going to have you do some. Okay, so let's have a look at this example here. So if I have 1 over x squared plus 6x plus 9, and I have 1 over x squared plus 8x plus 15. We need to find the LCD of this. This looks crazy right now, but let's try to make it look a little less crazy by factoring it. Okay, so the first thing you're going to do is factor. All right. So let's factor the denominator. So the denominator for this one, let's see, it's going to be x plus 3 and x plus 3. And for the second one, we're going to end up with x plus 3 and x plus 5 as our factor. So what's going to be the LCD in this case? That's ultimately what I'm trying to figure out. Okay, so I've got two fractions, and I'm going to draw two circles, and in here I'm going to notice that I've got an x plus 3 right here, and I've got an x plus 3 here, and they're sharing. Okay, so I'm going to put that x plus 3 right in here so that they're sharing between the two. Okay, the next thing I want you to notice is that there's this x plus 3 here, and there isn't another x plus 3 for it to share anywhere. So that this x plus 3 is all on its own. I'm going to put this one right here. And then finally, I've got an x plus 5 here, and it isn't sharing with anyone, so I've got my x plus 5 in here. Okay, so now my LCD in this case is going to be x plus 3, x plus 3, x plus 5. Okay, now even though it seems like I have x plus 3, why am I writing it down twice? Well, that's because only one of them is being shared, namely this first one here and this one here. Those are being shared, but then this factor here, it doesn't appear again anywhere else. So I have to write it down twice. And if you don't write that down twice because of this here, you're not going to end up with the right LCD. Okay? All right, so now I'm going to give you the chance to hit pause again, and I'm going to give you a few questions. So here they are. Okay, so here are 5 questions. There's 5 groups of rational expressions here. So what I'd like you to do is find the LCD, the lowest common denominator for each group. Press pause, and I will show you the answers in a couple of minutes. So give them a try on your own, please. Okay, so here are the answers. I've written them out for you. Hopefully you had some success, and if you have any questions, please make sure you ask. Thanks.